So far in hypothesis testing, we've talked about the fact that for our alternative hypothesis, we can have greater than or we can have less than. These are both what we call one-sided hypothesis tests, and they're called one-sided or one entail because when we go to shade, we either shade above for greater than or below for less than. We're shading one side of the bell curve. In reality, there's a third option, and this is what we're going to be talking about in this video. This is what's called a two-sided hypothesis test, and it occurs when we use an alternative hypothesis of not equal to. Now we need to be able to detect when to use this, so we're going to use it anytime we want to say things are different, things have changed, anytime we want to compare two things and we're not sure if it's greater than or less than, all we care about is in reality they are not equal to one another. Now let's talk about how this is actually going to change the test itself, because obviously it's going to change step 2, where our alternative hypothesis will be not equal to, but it's also going to change step 4. Remember, step 4 is our p-value, and when we go to find our p-value, we start by drawing our bell curve. Then we put our z-score on it, either above or below, depending on positive or negative, and then we shade it. Well, with a two-sided hypothesis test, we'll do exactly that. Let's say, for instance, our z-score was 2.31. In this case, we'd go to the upper half, because it's a positive z-score. When I go to shade it, though, it's a little bit different. When I have not equal to, I will always shade the most extreme end tail. That is, the tail away from the center of the curve. So if I've got one in the top half, I'll shade above. Now the thing here is that this is actually only a one-sided test right now, because I'm shading one side or above. It doesn't make sense for me to go ahead and shade all of this. If I did that, then the entire curve would be filled in and my p-value would be 100%, or 1. Instead, what we do is we go ahead and we mirror our curve across. That is, I'm going to take this divider at 2.31 and I'm going to put it right over here, exactly opposite of it, at negative 2.31. Then I will shade that end tail as well. Now this would seem like it's double the work. That I would have to find a p-value over here and then a p-value over here, but actually it doesn't. Remember that the bell curve itself is symmetric. So as soon as I find either this number or this number, well, they're equal to each other. So all I can do is I can find one of them, and then I can take that number and multiply it by 2 or double it in order to account for the other. So in order to do a not equal to, all I'm going to do in step 4 is find the most extreme end tail, above if it's a positive z-score, below if it's a negative one, and then double the end tail I find. Let's go ahead and look at an example here. Let's say that my alternative hypothesis was p is not equal to 0.40, and that I got a z-score of 2.31 like above. I'm going to go ahead and in step 4, I'll draw my bell curve. I put my z-score on there, once again, on the top half. I shade it, the most extreme side. And then because it's not equal to, I'm going to go ahead and I'm going to copy that down over on this side and shade that end tail too. Now once again, because this is symmetric, this one and that one are exactly the same number, which means I can look at 2.31 or negative 2.31 on the z-table. Go ahead, find that value, and then come back. Now when I looked at negative 2.31 on the table, I got a value of 0.0104. Once again, that's only for this left side though. To get both of them then, I'd go ahead and I just double that, which means my p-value for this problem is going to be 0.0208. Let's do one more just to make sure we got it. So moving that up there, let's say I have an alternative hypothesis of p not equal to 0.25. And let's say I have a z-score of negative 0.84. When I get to step 4 on this hypothesis test, I'd go ahead and draw my bell curve, and I'd put my z-score on it. Z-score is negative, so I'm going to be below the center. And I'm going to shade it because it's not equal to in the most extreme end tail. And then once I get that, I'll go ahead and I'll double it over to the other side. So shade that end tail as well. Next thing I need to do is find one of these two end tails. I'm always going to find the negative one because it's easier. I don't have to worry about taking like 1 minus or anything. So I want you to look at the table, find negative 0.84, and come back with it. Hopefully when we did this, we got a value of 0.2005. Now once again, because it's not equal to, I need both of them, so I'm going to double it. Get 0.4010 there. This will be my p-value. Now once again, this is in contrast to the one-sided, which is a greater than or a less than. When we do a two-sided, we'll find the most extreme end tail and then just double it.